And that next presentation is From Metadata to PDF, leveraging literate programming to generate human readable documentation. And presenting that today is Daniel Woulfin, who is a data associate at Global Ties for Children at New York University. He holds an MLS from Queens College, a PhD in history from Stony Brook University, and a BA from Rutgers University. His interests include knowledge organization, metadata, and data curation. Welcome, Daniel, and feel free to get started as soon as I stop my share.
Hello, and thank you all for having me. Let me share my screen. There it is. Just give me a moment. So this presentation you can see it, is, sorry, let me exit and start over. From metadata PDF, the main thing about this presentation is it was using literate programming, a programming technique to create human readable documentation. The problem that I was running into was pretty much how to create documentation for 4 large data sets that met FAIR standards. These data sets had not been created and fully processed and checked, and I didn't know how much time I would have. And by large, I mean, there were anywhere between 500 and 900 variables in them. So there was a lot that could go wrong. Basically, the main issue was how can I turn metadata files like DDI, which looks like this, into, and this is a DDI file from the DDI Alliance. It is their multilingual file to, I am so sorry, to a PDF that looks like this. This is not the PDF that was used. This is not the dataset project, but how can I do this? And how can I do this in 10 minutes if I need to? Because again, I didn't know when I was going to get these data sets. So what is literate programming? Literate programming is a methodology created by Donald Knuth in 1984, and it was a kind of a reaction to functional programming. So in functional programming, you're writing for the computer, you're writing in computer logic. The difference between literate programming and functional programming is that you're pretty much writing for a human audience, whether that be in the code or as the end result. So what you end up doing is combining or weaving or knitting a programming language with a markup language, what Knuth called a documentation language. And I love this quote because he says that it's more fun to write, and also that it kind of treats programming like a piece of literature rather than instructions to a computer. Basically, taking this technique, I was able to do what I needed to do and publish these data sets actually this week. So let's just start off with the basics. A programming language, for those of you who don't know, a high-level programming language is something along the lines of R or Python, C++, Java, etc. And it's used in something like literate programming to kind of really simplify what could be a very complex process and spit out the output. This could be converting data types, it could be parsing metadata files, which can be complex if they're hierarchical. It's wrangling data into different forms, generating visualizations, or even using existing packages to get very complex statistical analysis if you want. The other side are markup languages. Markup languages are kind of, they're HTML, they're LaTeX, which is a statistical notation markup language, scientific, I should say, but statistics too. And also Markdown, which is kind of more universal. And what these do in this process is they kind of, they set the formatting. They make sure that whatever you produce or whatever is produced in literate programming is going to look the same. Even if the data changes, the format will be the same. So even with the content change, that average or that list, even when they change, the actual way it looks in the document is going to stay the same. So let's, so basically what you end up doing is weaving. What's Knuth called weaving now could be called knitting. I have this quote by Walter Benjamin because it kind of does show that this is more of a literature, this is also a literature act. That quote is, work on good prose has 3 steps. a musical stage when it is composed, an architectonic one when it is built, and a textile one when it is woven. There's two ways to do this. One is with separate chunks. So you'll have your markup natural language, your programming language, your markup natural language, and we'll kind of keep going. The other way is to do kind of a single text and to use inline code within the markup and natural language. Here I'll see within R, which is the programming I'll be using most of the time, it's shown with backticks. So you would write like my name is backtick or name backtick, and it would give you whatever name that variable is. And instead of going on and on about it, I feel like I'm just going to show you. So I'm pulling up our markdown right now. I hope everyone can see it. I'm hoping no one's saying anything in the chat, so we should be good. And what I'm going to do here is open up a new markdown file. And basically, I'm just going to keep everything the same. It's going to give me this. And basically, this is the default markdown file. And what I'm going to do is just save it and then knit it. It takes a little bit of time, and you'll see this is giving me all of a sudden the natural language, URLs, summary, spitting out the summary, and including the plots. And basically, if you look at the, the file, you'll see you have a setup, two setups, one for the document, one for the code. Then you have natural language with the markdown in blue, then the code, programming language in gray, and then etc. Now, if I wanted to do something like this works, and I knit again, I have it wrong. All right, but it works something like that. But basically, yeah, so this is one way of doing it. Again, like cars, give me 1 second, I'll do this right. Yeah. I was thinking of another data set. And when I knit it, and I'll knit it now to a PDF just to show you how easy it is to switch. And now we have a PDF, and it tells me the max is 25. And so that's one way to do it. Another way to do it is basically to use what is called a notebook. And notebook is, looks something like this. This is a Jupyter notebook. It's in Python rather than R. And basically, you still see the chunks. So the first is a markdown chunk. So you'll see it generate, and then it's going to import the data. Then it will do the markdown again, and it's going to then describe the, well, that didn't work. Let's just see what went wrong. Okay, so something went wrong, but basically you can tell how it works. I know what went wrong. I'm not going to fix it right now, but basically the file is, I moved the file. And so back to the presentation. So that's basically what it would look like. And you can see how quickly you can just generate something. And like I said, these were very complex data sets. So skipping on, some of the things that these can solve is if you wanted to auto-generate a memo or something where you're converting like a lot of data and just getting the summary statistics, or the converting a metadata file into a report or documentation, just pulling it, it would be able to do that. Each of these documents would be static. So if you had to generate this weekly or generate 4 that would look the same like I did, or anything like that, you would be able to do it just by rerunning the same file with different data. You would be able to incorporate more sophisticated statistical techniques into reports. So for example, there are packages that go beyond summary statistics that will do factor analysis, or like the psych package, which will pull out lots of different kinds of standard deviation and correlations. And one of the things that this can solve is, as we all know, there's a lot of data and it gets overwhelming. And if we're presenting to any kind of different audience, you can target and change your audience to match that data. I mean, to match the audience. You can simplify the data and give what they need versus give them everything or overwhelm them. And finally, the best part about everything I showed you is it's free. This is open source, it's no cost. RStudio is free. Jupyter notebooks are free. It's just a pip library in Python. And this would be able to, if you are on a budget, be able to kind of reproduce things quickly, efficiently, and easily. So I did create a GitHub repository. I will fix the notebook before I will fix the notebook soon. And so for archivists and curators, such as what I was doing, which was a digital curation of all these data sets, this allowed me to convert metadata, in the case I'm showing you XML, a DDI file, a data documentation initiative, into a PDF. There were 4 steps, basically. First is, well, the XML files have to exist, so they're generated. Then they are read into the markdown file. Then that's accessed through the XML2 package. And then it's formatted into the natural language documentation format I want. And then finally it's knitted together as a PDF. The sample I showed initially is in the GitHub repository, but some of the same principles that I use in that sample would work on any sort of XML file, which could be useful for EAD files, for mods files, for lots of files, because there's nothing limiting you to one, and etc. The other way that this could be useful is, the other GitHub example I give is for librarians and administrators. So Kristen McEvely from the CSI actually proposed in a presentation to use IPES data to benchmark library metrics. So I tried to do that. And instead, what I ended up doing is creating an R Markdown file looking for outliers in circulation data, mainly using visualizations and summary tables. And that is also in the GitHub repository. Let's just see, I think basically, let's just take a look at that since I do have some time. But basically, like, you'll see I've posted resources in here for you, including lots of links. I also, for what I was just showing you, the RMD example, actually, I'll have to pull this up here. Files. Here you'll see what I ended up doing was, again, there are chunks, but within these chunks, these are just examples of the functions I used, explanations, and more chunks, just getting the data. These chunks are actually creating visualizations. So this would be a table from that data set of the most used, the states with the most circulation. The next chunk is showing basically what that looks like here for New York State, separating the number of public institutions versus private versus for-profit, then doing it via locale. Basically the same thing, just the numbers where they are, whether they're private, public or not. And let's knit it so you can see the whole thing at once. And basically, as I go, which I do hope you see, you'll see that in these examples, I've also given line graphs over time. And then this just told me that there was an outlier. So I started looking for the outliers. This is a box plot. There's clearly outliers for public institutions to get a master's degree. And then figuring out what that was. It was in 2020 CUNY John Jay College of Criminal Justice, which was significantly higher than the average. And basically, this could be generated just by change. If the data would change, if I was looking at another year, if I wanted to do averages, you can do all of that. And it makes it very easy to create static documents that could be used for assessment, could be used for assessment, could be used for return on investment, could be used for pretty much. Why did you skip? So I just skipped a slide. That's wonderful. Could be used to track any of this, create static documents that would just tell the audience what you want them to know. And basically, so website and social media traffic, it could all go into a single document, service evaluation reports like interlibrary loan, circulation analysis, comparisons to prior years, other institutions, staff time budget reports. And because they're static, you'll have a bit more control over if you had them in dashboards. So to me, that's actually a benefit if you're trying to control the flow of information, or just only certain people should see certain things. A static document's going to be much more beneficial. Finally, for the caveats, if you're going to do this, expect a learning curve, whether that's learning the programming language. It does require some programming skill, not a lot, and Stack Overflow and cheat sheets are definitely a friend. The examples I give are mostly in R because that's what we use at work, but you could also potentially, like I showed, use Python to generate this too, and to kind of play and explore and share. Also, just as an aside, LaTeX can be, you need language knowledge of the schema, the metadata file, and the data set. Like, you can use these techniques to explore them, but to create a final product, you kind of need to know the structure of the data sources for the Literate programming. And just, it can be very, very, very easy to get caught up in formatting, especially with LaTeX and CSS. I regenerated this documentation, I don't know how many times to get it right. Finally, my next step using Literate program as a curator at an academic center is to create templates and order to incorporate the documentation generation into the data pipeline, and also create curation reports so we can spot what's happening very early and bring it to the PI's attention, or fix it ourselves, because that ended up being the major problem, was fixing the metadata at the end before publication. I know I went quick, so thank you all for listening to me, and thank you for putting up with my technical issues. I'm sorry for them. Really didn't realize that the notebook was pointing to the wrong file. But yeah, any questions?
Thank you very much, Daniel. There is a question in the Q&A, and I encourage anyone else that has questions to throw them in there. I will ask the first one I see. Can Jupyter Notebook be considered literate programming?
Yes, it can. It's not the same as Markdown, but because it is, because it can also generate, if I were to go to File, and then I think it's Export, save and export, you have all these options to export this file, including PDF, Markdown, LaTeX, HTML, which would be generating that documentation. So I would say it can be considered literate programming. It is not the same as R Markdown, where you have it all in a single document because of the cells. But it does incorporate the Markdown language, which is a markup language, and a high-level programming language, which is Python, or actually R, if you have it set up that way, or anything else you might have. So yeah, it could be. It could be. Usually literate programming now is used to generate documentation and explanations. So, if you look at, let's say, a R package, you'll see that it has the documentation being generated with the actual files. And so I would say, yes, it can be. Would it be my preference to use? No, but I think it's a good example to show because it's Python. And it shows you can do it in multiple different languages.
Great, thank you very much. I don't see any other questions in the Q&A right now, but we can give people a couple minutes. We're actually running a little ahead of schedule, which is great. So if anyone has any questions, just throw them in the Q&A and we can just wait a few more minutes to see if they come in. And if they don't, then we'll just, go to our break a little early. And
everyone likes an early break.
But yeah, we still have a few minutes if anyone has any more questions. Just to add also, all of today's presentations are being recorded. So those recordings, as well as the slide decks from all the presenters, as well as any unanswered questions from the Q&A, will all be shared after the conference. So keep an eye on your inboxes, and everything will also be posted to SUNYLA.org as well. So keep your eyes open for that. Okay, I see one more question in the Q&A. What is the difference between using the knit function and pandoc?
That's a good question. Knit, honestly, there's probably not much because pandoc underlies everything. Knit is simply the knit button is just what's in RStudio, which just makes it super easy. But I'd have to look into knit-r, which is the package behind knit, to be able to really tell you that. But my instinct is that it's a GUI versus a terminal, a bash code. That's basically would be the main difference. I think the other difference is using this. Again, it's not that hard to, you can actually see previews. And I think that is a benefit, to be able to just jump and see the previews and then knit in the same place without having to jump into the terminal. But pandoc underlies everything, basically, as far as I can tell. But again, I don't have a good answer for that. I apologize. My instinct is the difference would be a GUI single click versus a bash versus bash.
All right, thank you. I'm not seeing any more questions in the Q&A. So I just would like to thank you one more time for your presentation. It was really interesting stuff here. And I think it was valuable to a lot of people in the chat.